Hello, I'm Miss Taylor with 5th grade at Chapel Glen, and today we're doing an investigation about the speed of a meteorite and how it affects craters.
Hey, thanks for that introduction. This is a cool lesson, or a fast lesson, or at least a big lesson. And I'll tell you why. We've been studying about the solar system and things in there. We've talked about the sun and inner planets, outer planets, how the earth moves. We've studied the different phases. And now we're going to look at something a little bit smaller, and that is meteorites and meteoroids and meteors. In fact, in the middle of our solar system is the sun. And I'm going to tell you, this drawing is not to scale. And we have the earth right about here. And the earth goes around the sun. We call that a what? An orbit. Thank you. It revolves. But there's other things out there in space. There are chunks of rock, glass, and metal that we call either meteoroids. We call them meteoroids when they're in outer space. When they're coming through the Earth's atmosphere, we call them meteors. And if they land and there's something left, we call it a meteorite. So you see the difference? In outer space, meteoroid. Coming through the atmosphere, a meteor. If there's anything left, it's called a meteorite. In fact, you might know a meteor by some other names. Falling star, shooting star. And they happen all the time. Every second, there are pieces of dust. As the Earth is traveling, as the Earth is going around the sun, it's traveling really, really fast. But so are these things here. But their orbits may be different. In fact, if you have a big chunk of glass, rock, or metal, we call that an asteroid. An asteroid. If it's small, we call it a meteoroid. And just every once in a while, these two things come together. And when that happens, it could be a small problem or it could be a big problem. Some scientists have found evidence that a large asteroid hit the Earth 67 million years ago, changing our climate. And in the fossil record, almost anything over 50, 60 pounds does not survive. What they mean is they haven't found anything bigger than that was living after this asteroid struck the Earth. We don't have to worry about that today, though, because today we're going to be studying how meteorites, if they're going slow or fast, how they affect the craters they make. So let me erase this for a second. So we got to check it out. We have a chunk of metal from outer space. And this chunk of metal is headed towards the Earth's atmosphere. Here's the Earth. Here's our atmosphere. As it's going and coming this way, nothing's going on until it enters the atmosphere. When it enters the atmosphere, it's going so fast that as it goes through the air, it's faster and faster. The air moves around it. The air starts to heat up. The asteroid or the meteoroid starts to heat up. It catches fire, and most of them get so hot, it's at nighttime just a shooting star. I saw one last week. I looked up in the sky at night, and I saw this. Just for a second, I saw it looked like a bright green light, and it just went like this. Like it just fell from the sky. What it was a piece of meteoroid that came in our atmosphere, got hot, caught fire, and burned up in just seconds. And my wife, that night, I said, Brenda, did you see that? She goes, yeah, I saw it. And so we both saw a shooting star, a falling star, or actually a meteoroid that turned into a meteor. It didn't hit the ground, so we didn't have a meteorite. I brought some of these with you. I'm going to let you hold these. There are 3 types of meteorites, and I've collected these, and people have given it to me. This one came from Russia. It is glassy. It's made out of glass, and if you hold it up to the light, you can actually see through it. This is kind of cool. This has traveled around the sun, I don't know how many times, but it was much bigger when it entered the Earth's atmosphere, burned up, and there was parts left. In Arizona, there was a famous meteorite that people have been looking for in Diablo Canyon. And here are 2 of these. This one came through and exploded over the Arizona desert, and pieces, boom, 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 landed in the desert. And so these have been found. My father gave me these 2 meteorites. I'm going to let you hold both of these. The glassy one from Russia, the 2 from Diablo Canyon. And then finally, I have a metal. It's made out of iron and nickel. Check it out. This meteorite has traveled millions of miles around the sun, and it was much bigger. You can actually see by its shape that it was starting to melt. A lot of it probably vaporized. And I know it's a meteorite because when I do this, I have a magnet, and it's made out of iron and some nickel, and it picks up. Would you guys like to hold these and touch these? Touch something from far away that's traveled. It was a meteoroid, it was a meteor, and it landed and caused an impact, and that's a meteorite. And that's what we're going to study today. When this thing came down, and it got, this is not the scale, but it started coming and it got really hot, and it actually crashed on the earth and made a crater. Now, scientists have studied two things: how big they are and how fast they move. And that's what we're going to do. We're going to do a model of this today. We're going to drop something that's going to be a model of a meteorite, and it's going to land not on the earth, not in the ocean. We're going to use flour as the model for the surface, and we're going to see if we drop it low, is it going to make a big crater or a small crater? If we drop it high, is it going to make a big crater or a small crater? Hey, let me pass these meteorites around for you to take a look at, okay?
This is the nickel.
Just be careful with them because they've come a long way.
That's the magnet.
Okay, so here's a video that has the 10 biggest meteor strikes in the world. And this is one of the famous ones. This is Behringer Crater in Arizona. This is probably one of the best preserved craters because it's in the desert. There's not been water or wind or plants that erode it. I actually visited this one, and people have studied this one. They think that this one hit 50,000 years ago, and it was so big that it vaporized all the rock from round and round. You can jump to the next one if you want to slide on over. That's probably the best preserved one in the world. Here's one up in Ghana in Africa. And this one they believe was made by an iron crater that's deep in that lake. And you can see in the middle of nowhere, there's round crater. And the next one, there's a lot in Canada. This one in Canada, though, it's kind of weird. It has a part in the middle because after this one, glaciers have come and scraped over it, so it's kind of hard to see unless you look at it from way high up. And there's another one, this one, I love this one. This was in Australia, and it looks like a ring of mountains. So this one has had a lot of erosion, and so they're starting to look like mountains. There's a few more. We can look at one or two more. This next one is in Canada. This was a double strike, maybe two meteorites. Once again, glaciers. But this last one I want to show you took place in Russia. And this one happened in recorded history. And for hundreds and hundreds of miles, it killed every tree and every animal that you can see there. So these meteorites, depending on how fast and how big they are do a lot of damage. Let's look at one of the very last ones. They had a hard time finding this one. This one was the Chicxulub crater in Mexico. And scientists have looked for evidence that this is the impact. When it hit, it changed the climate and the world, and all the dinosaurs died. It's a pretty big impact. It was huge, it was large, and it's really... Yeah, and the evidence for that is uridium, which is a mineral that is found all over the world about the same time that they think this one hit. All right, so you got a little bit of background. Let's do our experiment investigation using marbles and flour as meteorites and the Earth. You guys ready?
Yes.
Okay, if you look in your books on page 222, there's the investigation we're going to do. How does the speed of a meteorite affect the crater it makes? That's our question. And my question is, will meteorites that move faster make a smaller crater than a meteorite that's going slower? What do you think? So we have a meteorite, if it makes a meteorite crater if it makes a crater like that, if it's going faster, you think it will be smaller, larger, or the same size? What do you think? Go ahead and pick. It says, number one, state a hypothesis. Write a hypothesis by circling one choice and finishing the sentence. If a meteorite is moving faster, then it will make a crater with a width that is, what do you think, larger? If you think larger, circle A. If you think smaller, circle B. And if you think the same size, circle C. Okay? What do you think? It's up to you. I don't care which one you think because we're going to try to prove it. And then finish the sentence. All right, so most of you put A, that if it goes faster, it's going to be larger. A few of you put C, the same size. I'm very interested in that. Our next step is to identify and control the variables. You see, the marble is a model of a meteorite, right? And the flower is the model of the surface. So what are we going to keep the same? Do you think it's better that if we drop one marble, and then we throw one marble? Would that be a fair test? No, because throwing it's going to be, so we don't want to, so if we want to identify and control the variables, do you think it'd be good if we use a small marble than a big marble? No. We should do it the same way each time. So go ahead and finish that. It says, do it the same marble, same way. Now, let's look at number 3. The independent variable is the thing you're going to change in the experiment. And here's what we're going to do. First, we're going to use a marble, and we're going to drop it at 50 centimeters. Then we're going to drop it at 100 centimeters. You got that? So a marble at 50 centimeters to 100 centimeters. Then we're going to repeat the experiment with a steel ball. And we're going to drop it at 50 centimeters and 100 centimeters. So those are the things that we're going to change. That's our independent variables. Got that? And number 4, the last thing is the dependent variable. So I'm going to put IV by these for independent variable. And now the dependent variable is what we're going to measure. And you know what we're going to measure? We're going to measure the crater width. You understand that? So here's a crater. We're going to measure the width, how wide it is. And it might be big, it might be small. We're going to measure, that is our dependent variable.
So what you're going to put for number 3 is we're going to change the height. That's what's going to be changing in the experiment, the independent variable. The dependent variable, okay, we're going to measure the crater width. Measure crater width, and you have that up there.
Okay, on part 4 of our investigation, let's draw what the setup's going to look like. So make this drawing. First of all, you're going to have a pan, and this pan is going to have flour in it. Okay, you got that? Yes, yes. Label pan, and then
draw the picture
flour.
You draw your pan, make it big enough so you can see.
In that, we're going to have a meter stick. Meter stick. And it starts at 0 here, 50 centimeters here, all the way up to 100 centimeters here. That's going to be next to our pan. And then we're going to have a marble that we're going to drop. That's going down. And it should make a crater. And then finally, to measure the crater, let's make a little crater right here. To measure the crater, you're going to use a millimeter ruler in mm. That's a fancy name for a centimeter ruler. We're going to measure in millimeters. So make a drawing: pan, flour, meter stick, marble, millimeter ruler.
You're going to look at it, then you'll know what you drew. Sometimes we all do that. We draw our right thing, but we don't always do that. Make sure you put a label next to everything. Millimeter.
Okay, before we do the investigation, we have to have our procedure, our steps. And I'm going to try to do this as quick as possible. So number 1, on part 6, number 1, set up materials. Okay? Number 2, after you get the materials set up properly, number 2, we're going to drop marble times 4 and I'm going to make this at 50 centimeters. Do you understand what that means? Or do you want me to write it out longer? We're going to drop the marble 4 times at 50 centimeters. Number 3, we're going to drop, oh, should I put and record? You guys know, let's say and record on that. Drop marble times 4 at 100 centimeters and record. I'm going to make this easy for you. Ready? 2 more steps. Step 4, repeat steps 2 and 3 with, guess what? What? Steel ball. You know this. Good. Steel ball. And finally, number 5, draw conclusion. Now that is short, fast, but to the point. Set of materials, drop the marble 4 times at 50 centimeters, record. Drop the marble 4 times at 100 centimeters, record. Repeat the steps 2 and 3 with a steel ball, draw a conclusion. And that is our procedure. Nice, nice. Okay, if you look in your books on page 224, number 7, are you going to follow the steps you wrote? Yes or no? Yes, put a check by it. You're going to select a tool to measure the width. Yes, that's your millimeter ruler. Really small. I'll demonstrate that. And number 9, it says scientists repeat their tests to improve their accuracy. So we're going to do it 4 times. So we're going to end up doing it 16 drops. But see number 10, this chart. Go ahead and make this chart, and I'm going to make it, I think it looks like this, right? Yes. Okay, it's got a part at the top here for the title. And the title is Meteor, right, and crater width.
So write that in that top box.
Okay.
Meteorite and crater width.
All right, and then there's another box that's a little bit bigger like this, right? Okay, and it's divided into 4 sections like this, and like this, right? Yeah. Now, this one's going to be marble at 50 centimeter drop. What do you think this one's going to be?
100 centimeter drop.
Marble, very good, marble at 100 centimeter drop. What do you think this one's going to be?
Steel ball.
Steel ball. Thank you. You guys are getting this. Steel ball at what?
50 centimeter drop.
50 centimeter drop. And finally, the last one.
Steel ball at 100 centimeter drop.
Excellent. Now, since there's 4 drops, these are going to be our 4 places to record. And what are we measuring the width of the craters in? Miles, inches, centimeters, millimeters. Millimeters. So go ahead and in each box 16 times write mm. These are your units. And I think we're ready for this after you get all your mm's in there. Millimeter. Millimeter. And you guys think which ones will be bigger, the 100 centimeter or the 50 centimeter? What do you think? Okay, well, let's collect some evidence, some data to see if that's true. All right, make your chart look like this. And it looks like this in the book. I have to check out how yours look. Now, once we're done, you can interpret your data by making a bar graph and answering the questions on the other 2 pages. You got that? Okay, so I like this group here. They have their materials, they have their flour. One of the first things we want to do is we want to smooth out the surface, right? So we can tell. And so you just use your ruler. Dun, 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 dun. Sound effects are fun. Dun, 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 dun. And I don't know if you can see that in the camera, but that's pretty smooth. Can we see that okay? Next, we're going to do the marble. What do your directions say? Read your directions. Turn your page back. I got my materials ready. What am I supposed to do next?
Set up the material.
So, no, here's my meter stick, and so I'm going to go with, where's the 0 at? There we go. So I only need to do, the first 4 is only going to be this big. Would you hold this for me? You got that? Hold up. So there is 50. Keep it straight, and let's get it close. So from there, so I'm going to drop from here each time. You got that, right? Yes? And, okay, you're bending a little bit. There you go. And you be my drop guy, all right? So here's the marble. And so here's my marble. Now, should we throw it?
No.
Should we throw it up?
No.
At an angle?
No.
What should we do?
Drop it.
Just drop it. Let gravity do its thing. Okay, so bring it. Now it's come out this way a little bit. And is he about right?
Yep.
Yes.
So you have 3, 2, 1 meteorite. Everybody say that.
3, 2, 1, meteorite.
Bam! And look here, I see it's made a meteorite. Now that was a practice. So use your centimeter ruler. These little bitty things are millimeters. So I'm going to lay that down there. It doesn't matter where you use. Let's start like at 20. Go across the center. So it's got, there's 10, 15. How about how many do you think?
30.
No? Between, there's 10 of them, there's 15, about 17 millimeters. You see that? Now it's hard to use the end of your ruler because it's bent down a little bit, but if we do that, there's about 17 millimeters. So for my marble at the 50 centimeter drop, the crater width is 17 millimeters. So let's dig it up. What do we think we need to do next?
Do it at 100.
We need to smooth it, right? Smooth it. So let's try it. We do that 4 times. Go ahead. 3, 2, 1. And we measure it. After we do it 4 times, that way, what are we going to do next?
100.
100. So open up while I smooth this, open up the meter stick. That was 4 at 50. Do you think the crater is going to be larger or smaller? What do you think?
Larger.
All right, let's see. 3, 2, 1, drop. Oh my goodness. Check this out. Not only is it large, but it also bounced. Did you see that? Go ahead and put the centimeter ruler and see if you can see how wide that crater is. Across the middle of the crater. Okay. There's the crater right about there. And that one is a lot bigger than the other one. So once you do that 4 times, and then we're going to switch to
Steel.
the steel ball. That's just for fun. Let's take that out of there. Let's smooth it over. Go ahead and smooth it. Dun, 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 dun. Sound effects are good. Dun, 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 dun. There you go. Let's drop the steel ball from 100 centimeters and see what happens. Here we go. What do you think, guys?
Bigger.
3. Everybody say meteorite on 1. 3, 2, 1.
one.
Meteorite. Oh my goodness, look at that big bounce. Now I'll tell you, if it bounces, we don't like the way it bounces, that's a do-over. Make sure it does right, okay? Are you guys ready to start?
Yes.
Let's do some practice. I want you to practice dropping before you start recording.
So this is 100, so we're going to do 50. Are you trying to make it
No, you do 4 times. It's practice.
So we start at 50. We start at 50, don't we? Oh, sorry. There's 12. But you do it 4 times. Remember, that's you know if your results are consistent. Because if you do it 4 times,
That's a do-over, right? Because it looked like it went sideways, not straight down.
Let's see.
20 centimeters. I mean millimeters, 20 millimeters.
And last
Good job,
one was
guys.
12. 1, 2, 3, meteorite. Oh.
Okay, our kids are going to try and answer the question now about how the speed of a meteor affects the crater.
Wait, 6 meters?